Hello, my name is Dr. Siefker, and I want to welcome you to a survey of math history for educators, Math 6300 at Angelo State University. I just wanted to take a few moments of your time in order to introduce the course. Now, everything I'm going to say about the course is located on the website for the course on Blackboard. So why a video, you may say? Well, according to experts, this is my opportunity to introduce myself, to capture your attention, to build excitement, and to dispel any fears or uncertainties you may have about the course, as well as to visually demonstrate the course's relevance. So let's get started. Introduce myself. Hello, my name is Dr. Siefker, and I want to welcome you to a survey of the history of mathematics, Math 6300 at Angelo State University. Next, capture your attention. Wake up! Next, build excitement. And for this, we have a special guest. Yes, thank you. Thank you. Dispel any fears or uncertainties that you may have. For this, we have another special guest.
Now that I've scared the lights out of you, there's no need for you to be scared of this course.
Thank you. Make sure he gets paid. I don't want him coming back on me. Okay, finally, seems like we're near the end. So, now that all the objectives of the outside experts have been met, you would think that the video could be over, but no. You see the lovely lady behind the camera, Jana Finney, is also an expert here locally. She's been invaluable to me in developing this course. I couldn't have done it without her. She's had many great ideas, and she has worked very hard. So because she's told me it's a good idea to do this video, I'm doing the video. And when someone's that important to your success, you don't want to make them mad. So let me introduce the course my way, and hopefully instill in you the relevance for studying math history. There are many great reasons to study math history, but time doesn't allow me to go through all of them. So let me just relay two of them to you. I call them context and mentoring. And let me do it with an example from my academic history. When I was in grad school, I would take courses like real analysis, and I would open the book, read very little about what was in there, and come across a theorem, and there would be this beautifully displayed theorem. It'd be concise, it'd be clever, it'd be clean, and I can remember thinking, I couldn't do that. I couldn't just wake up one day, be given a task of proving something, and sit down and do it like it's done in the book. It was extremely discouraging, and what compounded it is when my professors would come in and write on the board, and they would give a near flawless lecture going through a theorem and its proof. So it was getting to the point where I was starting to think that maybe I wasn't cut out for mathematics, and I seriously considered quitting. I know that some of my students have felt that same way, and I'm willing to bet that some of yours have too. You know, that feeling of, I have no idea what we're doing, why we're doing it, and I'm not smart enough for it. You usually hear it in the phrase, well, I've never been good at mathematics. Well, in the process of studying deeper into the history of the concepts that I was studying at the time, I was able to discover that most of the proofs and the theorems and the concepts that we study were not just made up overnight, but they came in with a lot of trial and error and many people working on them at the same time. Mistakes were made, but eventually they got to the point where the proof was as it is in the book. What I was lacking was context. It was a huge relief to me to realize that great minds in the past made some terrible blunders in their logic, in their thought processes, in their proof skills. Now that I could do. I could make mistakes and I could learn from them. But part of what I was missing was something like, what's the purpose of continuity? Where does it come from? Why do we care about continuity? How did we get to the point where that was an important issue? And worse yet, how do you get from that issue to epsilons and deltas and using that in the definition of continuity? Again, the context explained that. These great mathematicians in the past were trying to solve real world problems. And in the event of trial and error again, they came to a point where they realized we need something like continuity. They weren't sure what that was, and it took many years to work that out. In fact, one of the smartest men in all of math worked 13 years to come up with the definition that we presently use. Well, this is a huge encouragement to me, and I hope it can be a huge encouragement to you and your students. The other thing I learned from these mathematicians is what I call mentoring. They taught me things like drawing pictures is a good thing. When I was going through school, drawing pictures was only for sissies or the dumb. But I learned that the geniuses of the past drew pictures and often used those pictures as their proofs, or at least to inspire the proofs that they were going to do. This again taught me to study the way that they solved problems, and I learned from them. I let them mentor me. And I'm hoping that this course will do a similar thing for you. And so in order to achieve these goals, we've come up with 5 tools, 5 objectives that we'll use in grading in order to help you achieve these goals in the course. The first one is our book, Mathematics, The Loss of Certainty by Morris Klein. This book is different than most books on math history, and I think you'll find it's more in a story format, and it'll be very interesting to you. But one of the things that I want you to do is to write a summary essay on every chapter, 1 a week. I know it seems like a tall order, but we can do it. With that essay, I want you to get involved in a discussion board. I'm hoping that this ends up being more than just fulfilling a requirement, but actually all of us learning from each other and picking each other's brains about what you caught in the chapter that I missed, and vice versa. I also want to give you an opportunity to do what I call a lesson plan. That may be the wrong word for it, but what it simply is come up with a presentation that you can give in your classroom in high school or junior high. I'm also going to have you select 3 of those and actually present them to the group online, of course, since we're not going to be getting together. But you'll have an opportunity to not only get feedback from us, constructive feedback, but we'll also get a chance to learn from you and steal ideas from you about how to present something. The last thing that we've developed is a timeline. We have a way for you to go in and keep track of great events, and important people in the development of mathematics. I'm a visual creature, so this just seemed to be the thing to do, the perfect thing to do. Hopefully it is for you to be able to see how the men and women that helped develop mathematics, how they entered into the picture as the problems with mathematics developed. And that's how the book approaches its story. It follows mathematics not from who are the men and women involved in it, but what were the issues, what were the problems that math was trying to solve, and what was the problems that math was having. So please, I want you to have fun in the course. I really want you to take this as an opportunity in order to be mentored, but also to come up with materials that you can use in your classroom. And if you have any questions, feel free to contact me either through my email, or even if you need to, contact me via phone. So again, welcome to the course, and I'm excited about the beginning of it.